What if I told you that in 1988, an Oregon engine builder discovered a way to make 450 horsepower from a Ford Windsor using nothing but junkyard parts that cost $300? Not with turbos, not with nitrous, not with some exotic race fuel, just naturally aspirated pump gas power from parts that Ford engineers never intended to work together. Picture this. It's midnight on a deserted stretch of Highway 101 outside Portland. Two cars line up at a red light. One's got a built 383 Chevy that cost $15,000 to assemble. The other's running what looks like a stock 351 Windsor. The light turns green. The Chevy driver expects an easy win. Instead, he watches taillights disappear into the darkness. The Ford driver just collected another $500, and nobody can figure out how a basic Windsor is walking away from legitimate race motors. This is the story of Keith Craft and the accidental discovery that revolutionized Ford performance building forever. A discovery so simple, so obvious in hindsight, that it made professional engine builders want to kick themselves for missing it. A combination that Ford's own engineers never tried, because they built an invisible wall between two engine families that should have been talking to each other all along. To understand why Craft's discovery was so revolutionary, we need to travel back to the 1960s, when Ford was developing their small block V8 architecture. The Windsor family, introduced in 1962, was Ford's answer to Chevrolet's small block. Clean sheet design, compact dimensions, excellent cylinder head flow for the era. The 351 Windsor, launched in 1969, was the big brother of the family, technically still a small block, but pushing the limits of what that architecture could handle. Meanwhile, Ford was also developing the 335 series, which would become known as the Cleveland and Modified families. These engines shared some design philosophy with the Windsor, but were considered completely separate entities. The 400 Modified, introduced in 1971, was a torque monster designed for big cars and trucks. It had a raised deck height and a massive 4-inch stroke crankshaft that gave it brutal low-end grunt. Here's where Ford's engineering departments failed to communicate. The Windsor team and the Modified team worked in isolation, different facilities, different design goals, different parts bins. Nobody at Ford ever asked the question, what happens if we mix and match? It was like having two separate toolboxes in the same garage and never realizing the tools were interchangeable. By the mid-1980s, the street racing scene was exploding, especially on the West Coast. Portland, Seattle, San Francisco, these cities had underground racing cultures where reputation meant everything and money changed hands fast. The problem for Ford guys was simple. Chevrolet had them beat on displacement. Building a big-inch Ford motor meant expensive custom parts. A Bryant or Scat custom crankshaft cost $1,800 minimum. Custom pistons added another $1,000. By the time you built a legitimate 408 or 427 cubic inch Ford, you were looking at $5,000 just in rotating assembly parts. Keith Craft ran a small engine shop in Gresham, Oregon, just outside Portland. He wasn't some big-name builder with magazine contracts and sponsor money. He was a working-class guy building motors for working-class racers. His customers needed power, but didn't have trust fund budgets. Every dollar mattered. Every horsepower had to justify its cost. The discovery happened by accident. Craft was rebuilding a 351 Windsor for a customer when another racer brought in a blown-up 400 Modified for scrap value. As Craft was tearing down the 400, he pulled out the crankshaft and set it on his workbench next to the Windsor parts. Something clicked in his brain. He grabbed his measuring tools. The 400M crankshaft had a 4-inch stroke compared to the Windsor's 3.5-inch stroke. But here's what made Craft's pulse quicken. The main journal diameter on the 400M crank was 3,000 inches. The Windsor block used 3,000-inch main bearings. The rod journal spacing looked compatible. The snout diameter, where the harmonic balancer mounted, was identical. Craft spent the next 3 hours measuring every dimension he could think of. Counterweights, journal overlap, thrust surface location, everything checked out. The 400M crankshaft would physically fit in a 3521 Windsor block, but would it actually work? The math was intoxicating. The 3521 Windsor had a 4,000-inch bore. Multiply that by the 400 mm's 4-inch stroke, factor in 8 cylinders, and you get 402 cubic inches. But here was the beautiful part. The Windsor block could safely be bored 0.30 over, taking the bore to 4.030 inches. That pushed displacement to 408 cubic inches. 408 cubic inches from factory Ford parts. Now here's where it gets interesting. The connecting rod situation required some creative problem solving. The 400M used longer connecting rods than the Windsor, 6.580 inches versus 5.956 inches. Using the modified rods would push the pistons way out of the bore at top dead center. But Kraft realized something crucial. The 302 Windsor used the same rod journal size as the 351W and 400M, but with a shorter 5.090-inch rod length. The solution was elegant. Use the 400mm crank, 302 rods, and custom pistons with the correct compression height. Except those custom pistons weren't really custom at all. Speed Pro already made a flat-top piston for 351W rebuilds that would work perfectly with the right ring gap filed. The first test engine went together in Kraft's shop over a weekend. He used a good 351W block from a 1974 F-150, had it bored and honed at a local machine shop, and assembled it with the Frankenstein combination of parts. The 400M crank came from a junkyard and cost $75. The 302 rods were $50 for a good used set. The pistons were catalog items, nothing special. Total investment in hard parts, less than $300. On the dyno, that first 408 stroker made everyone stop what they were doing. With a mild crane cam Edelbrock intake and 750 Holley, it pulled 427 lb-ft of torque at 3,200 RPM. Peak power came in at 438 horsepower at 5,400 RPM. These weren't race gas numbers. This was on 91 octane pump gas with a conservative 9.5.1 compression ratio. But the torque curve was what really got attention. From 2,500 RPM to 5,500 RPM, the engine never dipped below 400 lb-ft. It was a table-flat torque curve that made the engine feel like it had an invisible supercharger. In a street car, that meant instant tire smoke at any speed, in any gear. Word spread through Portland's racing scene like wildfire. Kraft's phone started ringing off the hook. Racers who'd been getting killed by big block Chevys suddenly had a weapon that didn't require a second mortgage. The beauty was in the simplicity. No exotic parts, no custom machine work, no special knowledge required. Hit 3 junkyards, grab the right pieces, bolt them together with basic machine shop prep. The first street race victory came 3 weeks after that initial dyno session. A local racer named Mike Torres installed one of Kraft's 408 strokers in his 1969 Mach 1. His first victim was a 454 Chevelle that had been terrorizing Portland's Marine Drive racing spot for months. The Chevelle driver was so confident, he spotted Torres a car length. Bad decision. The Mach 1 hooked hard and pulled 3 car lengths by the quarter-mile mark. $500 changed hands. And suddenly, everyone wanted to know what Torres was running. The technical advantages of the stroker went beyond just displacement. The longer stroke meant the engine produced massive cylinder pressure at lower RPM. The pistons were traveling faster at any given RPM compared to a stock stroke engine, which improved mixture motion and combustion efficiency. The rod angle with the short 302 rods was admittedly not ideal. The increased side loading on the cylinder walls would accelerate wear. But for a street racing engine that might see 5,000 miles a year, who cared? Kraft refined the combination over the next few months. He found that the stock 401 harmonic balancer was heavier than ideal for high RPM use, so he switched to a lighter 351W piece. The 400-month flex plate wouldn't work with Windsor bell housing patterns, but a 3V1W flex plate bolted right up to the 400-month crank's flange. Every problem had a simple, cheap solution. The camshaft selection turned out to be critical. The long stroke meant the engine didn't need aggressive cam timing to make power. A mild hydraulic roller with 0.510 lift and 218 degrees duration at 0.050 would support 450 horsepower easily. Compare that to a stock stroke 351W that would need 0.550 lift and 236 degrees duration to make similar power, sacrificing streetability and requiring expensive valve train upgrades. Here's what really burned the established engine builders. They'd been selling custom stroker kits for years without realizing the answer was sitting in Ford's own parts bins. Companies like Scat and Eagle were charging $2,000 for a 393 or 408 stroker kit with a custom crank. Kraft's Junkyard Special delivered the same displacement for less than the tax on those kits. The combustion characteristics of the 408 were nearly perfect for street use. The long stroke meant the flame front had more time to propagate across the cylinder. The turbulence created by the high piston speed improved mixture homogenization. Even with iron heads and basic bull porting, the engines would support 1.2 horsepower per cubic inch, race engine territory, in the late 1980s. Kraft's shop became the epicenter of a Ford performance revolution. He was building 2 or 3 408 strokers a week by mid-1988. His waiting list stretched 2 months out. Other shops tried to copy the formula, but often got the details wrong. They'd use 351W rods instead of 302 rods and wonder why the pistons crashed into the heads, or they'd try to use 400 mm pistons and end up with 7.1 compression. The secret sauce was understanding the stack-up of dimensions. The 400 mm's 4-inch stroke meant the crank throw was 2 inches from center. Add the 302's 5.090-inch rod length, and you get 7.90 inches from crank center to wrist pin at top dead center. The 351W deck height was 9.503 inches. Subtract 7.090, and you need a piston with a 2.43-inch compression height. Speed Pro's catalog number L2379F flat top was 2.416 inches, close enough that a .0010 deck clearance made everything work perfectly. The oiling system needed minor modifications. The 400M crank had slightly different oil passages than the Windsor design, but nothing that couldn't be fixed with careful attention during assembly. Kraft recommended drilling the oil restrictor holes in the lifter galleries one size larger to ensure adequate flow to the cam bearings. He also advocated for a high-volume oil pump, though not high pressure. The Windsor block's thin main webbing didn't appreciate excessive oil pressure. By 1989, the 408 Windsor stroker was showing up at drag strips across the West Coast. These weren't purpose-built race cars either. Street-driven Mustangs, Fairlanes, and F100 pickups were running 11-second quarter miles with basically stock suspensions and street tires. The combination of massive torque and streetable manners made them perfect sleepers. The Chevrolet guys were scrambling to respond. A 383 stroker small block Chevy cost 3 times as much to build and made less torque. Big block Chevys made similar power, but weighed 200 pounds more and wouldn't fit in half the cars that could swallow a Windsor. The Ford guys had found their silver bullet, and it came from a junkyard. Ford corporate eventually caught wind of what was happening in Oregon. Engineers from Dearborn flew out to Kraft's shop in late 1989. They spent 2 days studying his engines, taking measurements, and asking questions. The lead engineer, a guy named Tom Patterson, reportedly said, "We never thought to try this because the 400M was a truck engine and the Windsor was a car engine. Different departments, different applications." Think about that for a second. Ford had the solution to the displacement wars sitting in their parts catalogs for 15 years and never knew it. The bureaucratic separation between engine families had created an artificial barrier that prevented the obvious solution from being discovered. It took a small shop in Oregon to connect the dots. The racing success stories kept piling up. A Kraft-built 408 and a Fox body Mustang won the Super Street class at the 1989 NHRA Division VI Championship. Another 408 and a 1970 Torino dominated the Pacific Northwest's heads-up racing scene for 2 solid years. These weren't mega-dollar builds with exotic parts. These were $3,000 engines embarrassing $15,000 motors. The technical press finally caught on in 1990. Hot Rod magazine did a feature on Kraft's 408 stroker, calling it the poor man's 427. Carcraft followed with their own build, achieving 465 horsepower with aftermarket heads and a slightly more aggressive cam. Suddenly, every Ford performance shop in America was building 408 strokers. But here's the kicker. Kraft never patented the combination. He could have tried to lock it down, charge licensing fees, make himself rich. Instead, he shared the knowledge freely. His philosophy was simple. Ford guys have been getting our asses kicked for too long. If this helps level the playing field, I'm happy to share it. The impact on the aftermarket was immediate and profound. Companies that had been selling expensive stroker kits saw their sales plummet. Why buy a custom crank when a junkyard piece worked just as well? Within 2 years, the aftermarket responded by offering purpose-built 408 stroker kits that addressed the minor issues with the junkyard approach: better rod angles, stronger materials, precision balancing. But the prices came down dramatically because everyone knew the junkyard alternative existed. The 408 Windsor became the foundation for an entire generation of Ford performance. It proved that displacement could be achieved affordably. It showed that creative thinking could overcome engineering limitations. It demonstrated that sometimes the best solution isn't the most expensive one, it's the one hiding in plain sight. The durability of these engines surprised everyone. Despite the less-than-ideal rod angle, properly built 408 strokers would run 60,000 street miles without issues. The key was good machine work, proper clearances, and quality assembly. Kraft emphasized that the machine shop prep was more important than the parts themselves. A poorly prepped block with expensive parts would fail faster than a properly prepped block with junkyard parts. The tuning characteristics were remarkably forgiving. The massive torque meant you could run conservative timing and still make power. Where a stock 351W might want 36 degrees total advance, the 408 was happy with 32 degrees. Less timing meant less stress on the bottom end, cooler combustion temperatures, and better pump gas tolerance. Transmission selection became critical with all that torque. Stock C4 and C6 automatics would literally explode under the strain. Manual transmission guys learned quickly that stock clutches were inadequate. Kraft recommended minimum 11-inch clutches with heavy-duty pressure plates. Even then, skilled drivers could smoke the clutch in a single hard launch if they weren't careful. The fuel system requirements were surprisingly modest. The 408 would make 450 horsepower on a stock mechanical fuel pump and 3 8-inch fuel line. Compare that to a high-revving stock-stroke engine making similar power that would need an electric pump and half-inch lines. The lower operating RPM of the stroker meant less fuel volume required per minute. Kraft's influence extended beyond just the 408 combination. He pioneered other junkyard mixes that worked. The 460 big block crank and a 429 block created a 501 cubic inch monster. The 390 FE crank and a 352 block yielded 399 cubic inches. Each combination followed the same philosophy: use what Ford already built, just in ways they never intended. The cultural impact was equally significant. The 408 Windsor democratized Ford performance. You didn't need to be rich to go fast anymore. Kids working minimum wage jobs could save up enough to build a genuinely fast engine. The playing field was leveled, and street racing became more about driver skill and chassis setup than who had the biggest budget. By 1992, the 408 Windsor was so common that it had become the default performance build for 351W blocks. Magazine articles stopped explaining what a stroker was because everyone already knew. Parts stores stocked the specific combinations of gaskets and bearings needed. Machine shops kept the proper boring equipment set up because they were doing multiple 408 builds per week. The evolution continued. Racers started experimenting with different rod lengths to optimize rod ratios. The aftermarket developed specific pistons that addressed the compression height perfectly. Better flowing cylinder heads designed specifically for stroker combinations appeared. What started as a junkyard hack had become a legitimate performance platform. Ford Performance Parts eventually released their own 408 stroker kit in 1995, officially acknowledging what the grassroots had known for years. Their kit addressed all the minor issues with the original combination: better rod angles, forged components, precision balancing, but the price was reasonable because they were competing with the junkyard alternative that still worked just fine. The legacy of Kraft's discovery extends far beyond just the 408 Windsor. It changed how people thought about engine building. Instead of automatically reaching for catalogs and credit cards, builders started looking at what combinations might already exist. The mindset shifted from "what can I buy" to "what can I create?" Modern Ford Performance owes a massive debt to that Oregon shop in 1988. The Coyote 5.0 that powers today's Mustangs uses design principles that were proven in those early stroker engines: high piston speeds, optimized rod ratios, careful attention to combustion dynamics. The engineers who designed the Coyote grew up reading about Kraft's 408 strokers in magazines. The 408 Windsor remains popular today, 35 years after its discovery. You can still build one from junkyard parts, though finding a good 400-met crank is getting harder. The aftermarket offers dozens of stroker kits based on Kraft's original dimensions. But more importantly, the philosophy persists, that innovation doesn't always require invention. Sometimes it just requires connection. What Keith Kraft discovered wasn't a new technology or a revolutionary design principle. He simply looked at existing parts without the artificial boundaries that separated them. He asked, "What if?" when everyone else was saying, "That's not how it's done." He proved that breaking the rules intelligently could yield better results than following them blindly. The story of the 408 Windsor stroker is really a story about American ingenuity. It's about looking at problems differently. It's about not accepting limitations just because they've always existed. It's about a guy in a small shop who outsmarted billion-dollar corporations with nothing more than measuring tools and curiosity. Today, when someone builds a stroker engine, they're following a path that Keith Kraft blazed with that first 408. Every time a junkyard part finds new life in an unexpected application, it's a continuation of that philosophy. Every budget build that embarrasses expensive machinery carries forward that Oregon shop's legacy. The lesson extends beyond engines. How many solutions to complex problems are sitting right in front of us, separated only by artificial boundaries? How many breakthroughs are waiting for someone to simply connect dots that have always existed but never been joined? Keith Kraft showed us that sometimes the best engineering happens when you stop thinking like an engineer and start thinking like a hot rodder. The 408 Windsor stroker didn't just change Ford Performance, it changed how people approach problems. It proved that innovation doesn't require a massive R&D budget or advanced degrees. Sometimes it just requires looking at old things in new ways. Sometimes the secret to going fast isn't spending more money, it's spending more time thinking creatively. That Oregon mechanic who outsmarted Ford with a tape measure and some junkyard parts, he didn't just build engines, he built a philosophy that continues to influence performance building today. And that philosophy can be summed up simply: why buy it when you can build it? Why accept limitations when you can engineer around them? And why follow the rules when breaking them intelligently yields better results? What's the most creative parts combination you've ever seen work? Drop a comment below and let me know. And if you enjoyed this deep dive into grassroots engineering genius, make sure to subscribe, because we're just getting started exploring the stories of builders who changed the game with nothing but creativity and determination.